Let's rewind. You've seen this, Pangaea, some 200 million years ago, but we're going way further back to 1.6 billion years ago, when big pieces of India, Antarctica, and Ukraine were neighbors. So were parts of Africa and South America, Canada, and Australia. This is the strange geography revealed by this brand new model of plate tectonics that was released at the end of last year. It spans 1.8 billion years. And of course, here at Howtown, we ask, how do they know this? How did they come up with this model? How do they know where all these continents were a billion years plus in the past? So to find out, you and I are going to hitch a ride on two of these continents. I'm going to drop you off in Canada near some of the oldest rocks ever found. And I'm going to start on the other side of the world in Australia. We'll ride these patches of crust into the ancient past, and along the way we'll dig up some of the clues that scientists use to map a world that no longer exists. Our journey will span 4 billion years. Every pixel on this timeline is 3 million years, and this tiny fraction of this pixel contains all of human civilization. Okay, let's start rewinding. We'll give each region its own color so they're easier to follow, and we'll get rid of the ocean so we can have a better view. These are tectonic plates. They typically have some dense oceanic crust and lighter continental crust floating on top of the softer solid mantle. Just 65 years ago, most scientists didn't accept plate tectonics. People really didn't think this was happening.
I would have thought this would have been back in like the 1700s that somebody came up with this. But this was in people's lifetimes that are still around.
Yeah, totally. One of the first clues that this is happening is just looking at the continents. And this map was one of the first that showed semi-accurate outlines. Its creator, a Flemish cartographer who definitely could be played by James Cromwell, noticed that Africa and South America looked like they had been torn apart. Over the centuries, a few other people noticed the same thing, and other odd clues started piling up. Old shark teeth were unearthed high in the Alps. Identical plant fossils were found spread across different continents. Some people suggested that maybe land could rise and fall, connecting continents and creating new oceans. But in the 1910s, Alfred Wegener proposed a different theory. The continents were drifting. If you smushed all the continents together in what is now called Pangaea, those identical fossils matched up perfectly. Other scientists didn't buy it, though. For decades, they called the idea a fairy tale.
What was keeping the scientific community from acknowledging the possibility of this? Like, what's the big holdup?
It's funny because he was a meteorologist. He was working in a field that he wasn't brought up in. And I think that was an advantage for him because everyone else immediately encountered the problem. Well, how would this even work? Alfred incorrectly thought that Earth's rotation might be causing the continents to plow through oceanic crust like ships through ice. But physicists and geologists knew that those forces and the rock itself weren't strong enough for that to work. They really wanted more proof and a better mechanism, and they were about to get both. Sonar gave us a new way to scan the ocean floor, and in the 1950s, Marie Tharp spent years at the drafting table translating this kind of data into incredibly detailed maps. She would hand draw these. I mean, it's kind of incredible.
Wow. It looks like the map in the back of Lord of the Rings.
She noticed what looked like a long trench in the middle of the Atlantic. It stretched all the way up to Iceland, and you could actually see where it splits this valley. She pointed this out to her supervisor, and he was like, that's just girl talk. But eventually, he published the findings under his own name. Jacques Cousteau was also skeptical at first, so he dropped a camera into the middle of the Atlantic, revealing pillows of lava newly extruded from the center of the Earth.
It's because you have, an eruption under the sea. You sort of need to prove that the plates are actually moving. Volcanoes erupt in Hawaii too, but that doesn't necessarily prove plate tectonics.
They needed more proof that the ocean floor was spreading, and that proof came in the form of a miraculous little mineral called magnetite.
Ooh, has a cool name.
It's this iron-rich mineral, and when it's hotter than about 580 degrees Celsius, it's not really affected by Earth's magnetic field. But as it cools, it locks into alignment with that field and stays there.
It's like a built-in, burnt-in compass mark inside the rock?
Exactly. It's a compass that captures that moment in time. And it turns out that over time, Earth's poles switch places at irregular intervals. And you can see that switch in the ocean floor. The magnetite points north, then south, then north again, and so on, providing proof that the seafloor was spreading. But they still needed to explain what was causing the movement of the plates. Can you guess what the early theories were?
I mean, is it like little bath toys kind of just bobbing up and down on a sea of hot magma?
Yeah, I mean that is sort of what they were initially thinking. So the mantle isn't this ocean of molten rock. It's mostly solid. It can still flow over millions of years, but it looks like these currents have only a tiny effect on plate movement. Instead, they're pretty sure the main driver is what's going on at the other end of the plate. In subduction zones, the densest oceanic crust sinks into the mantle and pulls the rest of the plate with it.
You actually are like tugging the conveyor belt of the continents behind you as you sink?
Yeah, that's the main force, they think.
Yeah, what kind of scale of movement are we even talking about here? Like the fastest moving plate on Earth. Like how much is it moving in a year?
To help answer that very question, NASA sent up this satellite in 1976.
Well, it was the 70s, so of course it had to be a giant disco ball satellite.
They bounced lasers off all these reflectors to measure how much the continents were drifting. And they found, for example, that North America and Europe are moving apart at a rate of about 2 to 3 centimeters per year, and the fastest plate, the Pacific plate, is going 7 to 11 centimeters a year.
Wow, slow down, buddy.
Carl Sagan placed a plaque inside the satellite that showed Earth today and Pangaea 268 million years ago. This arrangement of Pangaea makes sense if you look at the age of oceanic crust. Red is the newest rock, blue the oldest. Rewinding so that newer crust disappears back into the mantle, we can follow how the plates must have moved. And Pangaea is where we find ourselves now. We've zoomed past a bunch of stuff. This is before mammals. There's not even dinosaurs yet.
Oh, wow. We skipped a lot of cool chapters of the book here. Okay.
Because there's so much more to go. I mean, we're going to go 4 billion years in the past. We're only like 300 million right now. Oxygen is thicker. We're surrounded by giant insects and the ancient relatives of amphibians and reptiles. It gets way harder to map the world before Pangaea. For one thing, hardly any oceanic crust survives from that time, so we can't rely on that. But luckily, there are other hidden clues. We'll get to that in a second, but first I want to thank today's sponsor, Storyblocks.
Storyblocks.
When I was making my last episode, I wanted to do a little scene where I represented all of the journal articles that I read by having them sort of rain down. So I was going to ask my wife to like drop them from a ladder or maybe like hide and throw them up in the air.
I was wondering how you did this one.
It just proved to be too complicated. So I just went on Storyblocks and found a piece of footage that worked and comped it into the scene.
Huh.
So yeah, they have unlimited downloads of different kinds of media.
Yes, they have
video,
images,
they have sound effects,
illustrations, and music.
So if you want to get started with unlimited media downloads at one set price, you can head over to storyblocks.com/howtown. You're on La Russia right now, which formed when your bit of Canada crunched into part of Europe about 400 million years ago. That series of collisions created a long line of mountains, and we can still see them today spread across continents.
How do we know that those mountain ranges used to be the same mountain range if they're spread across the globe?
This is a great question. For one thing, they all look like they're made from the same kind of rock, but they can also tell that they're the same age. Over on Joe's channel, we explain how scientists figure out when rocks formed. It's a technique called
zircon dating.
You can see the whole explanation and Joss and I forming a crystal lattice over on Be Smart. Zircon dating helped scientists figure out that these separate mountain ranges used to be one.
Made of the same stuff, cooked at the same time, probably not a coincidence.
Yeah. As we speed into the past, it's getting a little lonely because animals and plants are devolving back into the ocean.
It's a barren wasteland. Okay, got it.
And on top of that, oxygen levels are dropping. The model shows that a lot of the continents have drifted closer to the South Pole, and you're now near the equator. In Canada, they actually find hot water corals left over from this time.
That's a picture of a fossilized coral reef? That's super cool.
Meanwhile, in what is now Morocco, we find the remains of only cold water species. But there's actually a more precise way to tell that Africa was once near the South Pole, and once again, it's magnetite. When they find these little frozen compasses on continents, they seem to tilt in wildly different directions as you move back through older and older rock. But this makes sense if the continents are moving relative to magnetic north, and you can use this to reconstruct their positions so they're always pointing towards the same pole. Paleomagnetism is one of the most important tools in building a model like this. It should be said that it's not like the silver bullet. These dots are points in time when we have data from magnetite for different chunks of crust. And there are big gaps. As we move backward in time, uncertainty increases, and so does danger. We need to strap on oxygen tanks now because the microorganisms in the sea aren't pumping out enough oxygen for us to survive. And things are getting icy. Look at this photo from Norway. In the lower layer, you can see lines scratched into the rock by ancient glaciers. And then in the top layer, you can see the stones and sediment that those glaciers left behind. In many places, those glaciers seem to have scraped away eons of rock. Then the glaciers retreated, and new layers were added, creating this big age gap. You can see this in the Grand Canyon, where there's a jump of over 1 billion years. Some people think that during this time period, most of the globe was covered in ice, with a belt of water in the middle. We're now 780 million years in the past, and we've joined the supercontinent of Rodinia. It's got pieces of most of the continents, so the gang's all here, but they're all scrambled up.
Quite jumbled. All right. I'm nodding because I'm taking your word for it, but inside this is like very hard to believe.
I mean, it is hard to believe. It's hard to believe that things made a journey this far. I mean, the paleomagnetism is a big help in sort of proposing where things were, but then they find these other clues, like there are layers of rock in the Grand Canyon from this time period that perfectly match up with layers of rock in this outcropping in Tasmania, which suggests that they were both once part of a shallow inland sea that formed right here. It's still worth noting, though, that this configuration isn't certain. This is one recent model, but of course there are other scenarios that people have proposed. And it's also hard to say exactly what Rodinia was shaped like. These chunks of crust could have been warped in different ways, extending the coastline or leaving gaps that would have been filled by ocean basins. Over the next hundreds of millions of years, we'll float apart and then come back together again.
We needed to do our own thing for a while, but we're coming together. Yeah. We're coming back together.
This new supercontinent is called Nuna, or Hudson Land, or Columbia, depending on who you ask. And this is one of those moments where, again, you can see the rocks. There's part of Queensland that looks exactly like the rock up in this part of Canada. And so they think that it just formed, broke off, and drifted over and became part of Australia. So this piece of Canada is still in Australia today.
A farewell gift.
No matter where you go, part of me will be traveling with you.
When we're going this far back, like, are there the same number of tectonic plates as there are today? Or do these things like hook up for a little while and you get new ones breaking off?
Yeah, I mean, it's always changing. So yeah, there's not the same number of tectonic plates. You could see over time new cracks forming, others closing. What is maintained is the cratons. So these chunks of continental crust that are part of the plates that have persisted to this day. Canada is made up of a bunch of different ones that are all kind of mushed together. You can almost imagine like chunks of clay that are slowly being added to create what is now Canada. Australia is the same deal. Both Australia and Canada have some of the oldest cratons. Even though they're going to drift further into the past, it's probably not safe for us to stay on them any longer. So I think we got to hop off the crust, watch from a safe distance. Over the next couple billion years, these cratons are going to probably spend some time under the ocean, under other rock. So it wouldn't be a good place for us to stand. In the deep roots of some cratons, diamonds are forming. And so where these oldest bits of crust ended up is where most diamond mines are found today. Below us, cratons are melting back into the mantle, but a few remain, including the Kopval craton from South Africa and the Pilbara craton from Australia. And because of the kind of rock that they're made of, scientists think they might have formed in a similar place and been part of maybe another continent that they cleverly called Volbra.
It's a celebrity couple, but it's cratons.
They both have these weird little spherules. Do you have any guesses about where these might have come from?
How far back in time are we now?
This is 3.47 billion years ago.
If I remember right, like life is starting to happen around this time.
That's a good guess, but these are unrelated to life, as it turns out.
Oh, darn.
These actually come from a meteor strike. So a meteor hits, it liquefies the rock, and it splashes up in this little spray that cools into these little marbles.
That's horrific. That's so violent. Like, for something to hit so hard that it melts the earth into glass droplets.
And that violence is becoming more common. We're getting hit by quite a lot of meteors. And the best evidence for this bombardment doesn't come from Earth, it actually comes from the moon. Here you can see one of the moon's giant impact craters. Apollo 15 visited its rim and grabbed a chunk of this rock. It turned out to be 3.8 billion years old, and it carried all the signs of being shocked by an impact. A bunch of other lunar samples also support this idea that there was a spike in meteor strikes around this time.
So those marks have been left on the moon because the moon doesn't have tectonic plates. But are there any craters left on Earth?
The Earth is too alive and vibrant for something like that to stick around.
Whereas the moon is just a scarred husk of violence that records every punch it ever took.
By now, all of the cratons that we've known have disappeared. They don't exist yet. But somewhere down there in the crust, a very special rock is forming. This rock will survive to the year 2025 and be held by Joe Hansen.
This is the rock that hadn't been recycled down into the Earth and messed with by chemistry.
And now scientists are studying this rock to learn more about Earth's infancy.
Now I can look at that rock and say, I know when you were born. I've known you your whole life.
The world is now new, and there's a mess wherever you step. So let's reverse course and watch the planet churn back towards the present.
It really extends your idea of the living world. Earth is not just like a canvas that stuff is painted on.
Plate tectonics built the shallow seas that cradled the first life, and then shattered that nursery into 1,000 niches where new creatures would have to adapt and evolve. And the process isn't done. This is the final image that Carl Sagan smuggled aboard that disco ball satellite. It's what we think the Earth will look like in 8 million years, transformed once again. Howtown is just 3 people, and we could really use your support to keep on making these videos about how we know what we know. I'm going to be putting up a sort of behind-the-scenes video about this episode on our Patreon, and that's also where we meet monthly to talk about hot new science papers in our Science Paper Book Club. Our work is also supported by IMI, the Independent Media Initiative, and the Alfred P. Sloan Foundation. They're enhancing public understanding of science and technology in the modern era.